Hey guys, my name is Ryan. I saw this proof online, this question I wanted to be able to try. So it's asking, prove that 2 to the n is greater than n squared for all values of n that are greater than 5. And so whenever you see something like this, you should immediately think of induction. So I'm going to start the induction proof by using the lowest value, which is in this case 5, since n is greater than or equal to 5. So I'm going to test, does it hold true for n equal to 5? If n equals 5, then we're going to have 2 to the 5th, which is 32. And is that greater than 5 squared, which is 25? And obviously it is. So it holds true for the first case. Now I'm going to assume that for all values of k, that 2 to the k is greater than k squared. I'm going to assume this to be true, and now I have to figure, if this is true, does it work for one more? And this is the main part of it. If I just add 1 to k, does that hold true? And so I think the biggest thing to start off that I'm going to do is I want to break this down right here. I have 2 to the k plus 1. Generally, working with exponents, I don't like that. I'd rather rewrite it as 2 to the k times 2 to the 1. Exponent laws is where you get the k plus 1. And 2 to the 1 is just 2. So this is equal to 2 times 2 to the k. And so we're asking is 2 times 2 to the k bigger than k plus 1 squared. If you notice, this is very similar to the assumption I made earlier, right? It's just multiplied by 2. So I'm going to take this assumption and I'm going to multiply both sides by 2. And I'm going to get that this is the same as saying 2 times 2 to the k is greater than 2k squared. Okay, now I'm assuming this to be true, right? I am saying that I know that looks like a z. I'm saying I know that 2 times 2 to the k is greater than 2k squared, right? So let me ask you this. If I know that a is greater than b, and I'm trying to prove that a is greater than c, if I can prove that b is greater than c, then that would have to mean that a is greater than c. And this is just because, you know, I know a is bigger than b. If I can show that b is also bigger than c, then it's like, you know, obviously a is going to be bigger than both of them. And so this comes into play here because we're assuming that this is greater than this, right? This is our a, this is our b. This is our c. We're trying to say, is 2 times 2 to the k bigger than k plus 1 squared? Well, we know it is if our b, which is 2k squared, is 2k squared greater than k plus 1 squared. And if you're wondering like where you get the idea to do that, I think the biggest thing to think about is just that, like, you know, it's really hard to compare like a 2 to the k to a k squared. It's just not easy to manipulate equations like that. You know, it's hard to isolate the k. But if you have the k as the base in both of them, like this is 2k squared and this is going to be a quadratic as well. Quadratics are much easier to work with and solve and manipulate. So this is what we're trying to figure out now. Is 2k squared greater than k plus 1 squared for values k greater than 5 or equal to? And so I'm going to expand this, which is just k squared plus 2k plus 1. So I have 2k squared greater than k squared plus 2k plus 1. I can subtract a k squared from both sides, and I'm going to get this k squared greater than 2k plus 1 for k greater than or equal to 5. And you know, there's multiple ways to go at this, really. but it's a very basic statement. I mean, I think the best way to go at it is just common knowledge of exponential growth. Like this quadratic is going to grow much quicker than a linear function. I can plug in when k is equal to 5, our left side is 25, and our right side is just 11. And then when k is equal to 6, our left side is just 36, our right side is just 13. And it's obvious to see that the left side is growing much more quicker than the right side. It's just basic understanding. And so we know that k squared is greater than 2k plus 1 for all values that k is greater than or equal to 5. And because we proved this, this is basically saying that yes, this is true. We just proved this. And because this is true, because 2k squared is greater than k plus 1 squared, and 2 times 2 to the k is greater than 2k squared, we know finally, this is the same thing as 2 to the k plus 1, that therefore 2 to the k plus 1 is greater than k plus 1 squared. And because we were able to prove this, we have proved using induction that for all values n greater than or equal to 5, that 2 to the n is greater than n squared. Thank you guys for watching.